16 then says universal set is integers, the set of integers. A is an integer, obviously, where x is, or the elements of A are bigger than 0 and even. And B, again, x is an integer, but between 3 and 17. It says, find B's intersection with A's complement. So B would be in listed form, 3, 4, all the way to 17. And then A's complement would be odd integers, so 1, 3, 5, 6 to infinity, 6, 7 to infinity. And then where do we have an intersection then? Well, we're going to have an intersection with all of the odd integers from 3 to 17. So B intersection A complement is going to be 3, 5, 7, not 6, 15, 17. There we go. Question 17, maybe give myself a little bit more space here. It says draw a Venn diagram to show that information. And our three groups then are, we've got primes, square numbers, and then we've got multiples of 3. So if we wear 3 of them then, 1 is a square, but not a prime or a multiple. Let's use a different colour. 2 is going to be a prime, but not a square or a multiple of 3. 3 is going to be a prime and a multiple of 3, but not a square number. 4 is going to be a square number, but not a multiple of 3 or a prime. 5 is going to be a prime, but not square or multiple of 3. 6 is a multiple of 3, and that's it. 7 is a prime, and that's it. 9 is a multiple of 3 and a square. 11 is a prime, but not a square or multiple of 3. And 16 is just going to be a square number with no other values outside of the union of those three sets. And then be careful with part B. It doesn't ask us for the elements of that set, M complement intersection P. It asks for the number of elements. So where is that? M's complement, so everything that's not in M. There we go. And its intersection with P. So it looks like it's going to be all this bit. And how many values have we got there? We've got 4.